Okay, hey folks, I'm doing Gruber, and let me power up my slide software. Yeah, so I'm doing Gruber, and I'm going to talk about modular frontends and big apps with Browserify. Because since Browserify is more like a library that enables you to do cool things and not a framework, and it doesn't give you structure for your apps. It's still your task. So there's a couple of things I learned, like working on big apps that I want to share. So why would you even need Browserify? Like this quote from the Breakbone JS website sums it up perfectly. Like it's all too easy to create JavaScript applications that end up as tangled piles of jQuery selectors and callbacks. And I think we've all been there. So wait, let me go into full screen mode. Cool, can you read that? Okay. So the first question you might ask yourself is, how do I best bundle Browserify? So what I usually do is in development, you bundle on every request, so you always get the latest bundle. But in production, you probably would want to serve from disk, so you can use all those caching things and let static file servers do e-tags and shit like that. So if you bundle every request, that's how it looks like. You use the Browserify API. I think you probably saw that in Thorsten's talk too. So your bundle pointed to your entry file, and if you pass debug true, you get source map support, which is great because you don't want to debug inside like a 10,000 lines big file. So yeah, but this can be slow. Like I've seen this go up to 500 milliseconds. So it's kind of okay for development. And it has the nice advantage that you're never writing to disk. So you don't check in your bundles, you don't get merge conflicts. So here's what your typical workflow would be like when you serve from disk. You would use the Browserify CLI. This again takes the app that has an entry file at libbootboot and bundles it into static/bundle.js. And because you don't want to type this over and over again, you could write a make file, or you could use the package.json's scripts key. So what you could do is you have a build script, which does exactly that, and perhaps have a start script that does a build and then fires up your server. Yeah, so you do npm run build or npm start or npm build, npm start, something like that. A nice thing that Substack wrote is Watchify. And Watchify watches the file system and recompiles only the changes. This is huge, like for a big project where you have dozens of dependencies and you have like D3 or something like that. You don't want to recompile your whole bundle every time. That's just too fucking slow. So with Watchify, you basically have the same syntax, CLI syntax as with Browserify, but the process stays open. So you could have a Watchify script in your package.json, and then npm run Watchify, and use the ampersand to put it into the background, and then npm start. So those are basically the easy ways to bundle, or the most obvious. There are some libraries that do cool stuff for you, but I usually go for the simple things. Okay, that's bundling. Next thing that you need for big apps is structure. So because you might have server-side JavaScript, client-side JavaScript, server-side templates, client-side templates, style sheets, and things can get like really messy if you don't have good structure for you. You could use frameworks, of course. You can always use frameworks, but I prefer not to because I like freedom. So one case might be a client-side heavy app, like a single-page app. And the way I usually do is it is like you have a server file, you have your server libs, you have static files, bin scripts, like that's the usual thing. But then I have a browser folder. Oops. And inside this browser folder, for every feature you have, you put in there your browser code, your template, and your style sheets. So feature could be like for a chat application, the input box or the message list, or it could be something that doesn't even have any DOM. Like that's all the nesting I ever have. Like never nest deeper than 2 levels. Just have it flat. And you might then have like 20 or 30 folders inside /browser, but that's just easier to work with than having like deep nested things. And some common features I have is a boot feature, which is the browser entry point, which ties everything together, and a layout for like common shared things. And when you have this structure, here's here's the server, like for a client-side app. Rewrite URLs to be / so it serves the index HTML. But that's not the core point of this talk. So this is how I would write a view object or a small feature. So given a chat app, you need an input box, and that input box might be like an input element, and it has some DOM surrounding it because you have a fancy design and you need extra elements. So it's a good thing to make an abstraction for that. So we have an input class, and that input class sets this dot element. And well, there's a bug in here. Wait. Okay, so what's going on here is on the client, I require the file system. And there's some Browserify magic to make that work. And I load my static files for that feature into memory. And I will show you in a second how that actually works. So just assume that in the template var we have the HTML. Then I use a library called hyperglue, which turns that into DOM, and you can do things like the button text should be sent, or the button should have HTML of send and an additional class name or something like that. And then you bind events to your DOM, and you insert the CSS. Insert CSS is a library by Substack that inserts this bundle of CSS into the DOM if it's not there already. Then, nice thing is, you use Node Core. So you make your input view inherit from event emitter. As you see, we required event emitter the same way you'd require a node, and inherits the same way you do it in Node. And then in your key down event handler, if the key pressed is the enter key, we emit the message. And I'll show you in a second why that's super useful. And for those file system magic things, there's a library called Brfs, which you'll find on GitHub or NPM. And when you bundle your JavaScript, you say transform source code with Brfs. And what this does, it does abstract syntax tree analysis. And when it files a call like this, it in place replaces it with the actual file content. So what the browser sees is more like this than later on. And when we have, So when we have this in place, in our boot file, we require our input view, and we require other views or other libs that we need for our app. We instantiate them, we insert them into the body or into any other element. And that's why it's handy to expose like view.element. Then when the input gets a message, we send it to the API. And when the API says, hey, there's a new message, we put it onto the list. And this file, like your main boot file, could become like really large, especially if you have like a huge app and you have like 30 components that you need to connect to each other. But I'd rather have like one file that shows you how every component interacts with each other than having to look at like my list component and see how it calls out to the API component and having my input component like post to the list component. That's just bullshit. So this way you have it explicit. I think that's very nice, and that makes it very maintainable. So whenever someone goes to your app, he just looks at your boot file and he sees, this is how parts interact with each other. And here we're using event emitter style. So for example, backend guys also can read the code, but we could also use stream style. So if we assume our libraries are written in a streaming manner or they expose streams, we can say we pipe the input to the API and pipe the API to the list. And especially for projects with a lot of widgets where a lot of stuff is going on, having one chain of flow for all your things is very, very valuable. Yeah, that's how you avoid jQuery spaghetti. And there's this other use case where you have more server-side code too. So what you could do in this case, what I learned from reading TJ's code, is you have a lib folder, and in lib you have a folder for each feature. And this folder contains like server-side and client-side code. So on the server you say require messages, and on the client you say require lib messages.js. You could even make this nicer, but I think that's cool already. And then what I like to do on the server side is I use stack, which is like the middleware part of Connect, but without all the middlewares. And so you just put all your features into the stack, and the feature then says, okay, I will react to that URL, or I won't react to that URL, or I will forward an error. And I assume you're all familiar with that middleware pattern, also known from like Ruby from rec and all that. And you write your client side just like with the single page example. Okay, so this is how I usually structure my apps. So if you keep it flat, it's so much easier to understand your code base and to maintain it and everything. Okay, next thing that comes up a lot with Browserify is big bundles. Like 200 kilobyte bundles isn't something that you run into if you have too big of an app. That's just a normal thing. Or it could be 1 megabyte. And you definitely don't want to have a 1 megabyte bundle. So what you need to do is either you need to have less in your bundle, or you need to split it up and do lazy loading. And the first thing you should do is you should analyze what you have in your bundle. What's actually taking up all that space? And there's a super handy tool called Disk by Hugh Kennedy, I think. And with this, you take like your entry file and it creates HTML. And I pipe it into bcat, which pipes it directly to my browser. So I can show you this right now. You diskify, I have a project here. And pipe it to bcat. And you wait. this is what you get. That's pretty nice, huh? So you can switch between file count and file size. File size is usually what matters most. So you see, okay, this bundle uncompressed is 140 kilobytes. If it's gzipped and uglified, it's probably not that bad, but it serves well as an example. So you see, okay, my Node modules folder is quite big. Browserify build-ins, which is actually Node core, is not that big in that case. But if you require buffer or readable stream, you will get like so much code. So we can see, okay, Engine.io stream, wow, that's 50 kilobytes. CRDT, 30 kilobytes. And like you can go down the dependency tree as much as you like, and you can inspect stuff, and you could say, okay, Engine.io stream is quite big. Do I really need WebSockets, or should I use a more lightweight library? So yeah, this is super useful. Definitely check it out on GitHub. And also bcat is super useful. Okay, let's say you did this, but you can't really get rid of any of those dependencies. So the next thing to do is to split up your bundles. We can do that. We can do that with the CLI. So let's say you have some graph stuff that you, for some visualizations, but you only need it like on a certain widget or on a certain page. So when you bundle your boot file, you could say exclude this file. And then you make a second bundle, like at static/graph.js, and you say, okay, this just exposes the graph. And you don't have to change your code at all. Like, there's no code change between doing this and between, oops. Oh, I forgot my Wimfu. And doing this, or rather this. Like, you don't need to change the code between those and those bundles. Of course, you need to change your HTML, because here you only insert your bundle into the HTML, here you insert two files. This works with your libraries, but it also works with Node modules. So say you have D3 and Fabric, which are two like awesome graphing libraries or visualization libraries, but they're also like super huge. So you exclude them in this bundle and expose them in this bundle. Oh, and by the way, my code for this is on GitHub. It's here, so if you wanna like read up on those things, they're all there. And then for like a traditional server-side app, in your HTML, like if it's the index page, you just require the bundle. If it's the other page, you require the graph and the bundle. Or if you have a client-side heavy app or a single-page app, you use just any JavaScript loader and lazy load your bundle. And then you can just require what you added in this bundle. So doing this, you should be able to get down your bundle size a lot. And of course, always gzip and use uglify in production. And there's a module Substack is working on, which is called Undead, which is doing dead code removal. And when this is, yeah, that's a pretty rad name. So when this is ready, oh, and it has a nice logo, I think. Wait for it. Oh, no, it doesn't. It had one. Okay. So currently, when you require util.inherits, you will get the whole code in the util package, although you just need that one method. And with Undead, you will only get the source code for the inherits function, nothing else. So when this is done, like Browserify bundles, for example, will be so much smaller than component bundles. Okay, another common question is how the fuck do I use non-Browserify libs or libraries that aren't on NPM? Because apparently, like, not everyone publishes to NPM. And usually it's either standalone libs that expose themselves onto the window object, or it's components. I found component to be a great source of front-end libs. So with standalone libs, like jQuery for example, one thing you could do is you just don't include them in your bundle. You have a separate file. And in the top of your JavaScript, where you require all your things, you kind of fake import it or fake require it from the window object. So it's still explicit. Or you wrap the library. You make it compatible with NPM. Excuse me. So libraries always do like window.lib or like this.lib or something. You find that, you replace it with a module.exports. Then you add a package JSON to that library, and you could, for example, use the npm CLI to generate one for you. You push your fork to GitHub, and you make a pull request. So usually you can't just make a pull request, or people won't just accept your pull request because they don't always use Browserify, right? Like jQuery would never switch to be a Browserify only library. So two things. Browserify has a -s flag for standalone libraries. So when you do this, it will actually somewhere in there have like if not module.exports, then window.lib equals lib. It will do this UMD thing. So you could tell them to use this in their build process, or you could do that yourself. And then if it hasn't been published, great, you just publish it on NPM, or you can source your fork. That's what I usually do. Like in your package JSON, you can use Git URLs and point to the branch of that library that you push to GitHub that you made NPM compatible. And then you do NPM install and it all just works. Okay, but what if it's already a component, for example? And there's like, you should check out the component wiki if you haven't already. Like this is all front-end code. With NPM, you sometimes have a hard time finding front-end only code. So this is a great resource. But most of them, or a lot of them, aren't published as node modules. They're just published as components. So how do we convert them? And it turns out Browserify supports a browser field in your package JSON. And with that, you only need to change the package JSON of the component and potentially the dependencies in order to make them work with NPM or Browserify. And the reason you have to do that is component has this convention where someone could have like what string/get, and you require it as get in your code. But of course, the name get is taken in NPM. So in your package JSON, no, wait. So this component is published as a component, for example, at /get, but it might already be in NPM, but it's called get component. It's not called get. What? So there's a name discrepancy. So you fork that component and you add a browser field to the package JSON. And you say if something requires get, it should actually require get component. So you do this, you make a pull request, and then they will work with component and npm. Okay, and I think the last very important topic is testing. How can I ultimately test my front-end code if it's written with Browserify? Like, do I just have a browser test that developers need to start themselves, or is there a CI that I can use? And there is. So to be able to hook into a lot of the available Browserify infrastructure, you should use a test library called Tape. And Tape is a browser-compatible version of Tap, which I assume a lot of you know. And Tap is a JavaScript implementation of the test anything protocol. And with Tap, your tests look like this. We test if JavaScript work. We say, okay, I will do two assertions. The first one, then I will set a timeout, and then I will do a second assertion. Like with Mocha, you would have, or it works, I don't know. You could also use Mocha, but it's nicer to use Tape. And then when you wrote your test using Tape, you can, for example, use the testlink CLI. And when you install the testlink CLI, you bundle your code, pipe it into testlink, and it will run it in a headless browser on your machine, and it will have a proper exit code. So you run this, it runs your code in the browser, you get an exit code. So for failed tests, you would have an exit code of 0. So this way, you could, for example, have this in your npm test script, which would then be Browserify, blah, 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 like this up here. So that's for running tests locally, but you want to test in a lot of browsers. So there's the testing API, or the hosted version of testlink. And there's a nice tool that Thorsten wrote, I think, which is called testlingify. So all you have to do to make your project being your open source project being tested in testlink is you go to your project, you say testlingify. This adds all the webhooks on your GitHub. You create yourself a batch. You add that to your README. You git push, and your tests will be run. So it's like a free CI for everyone to use. Substack is working on private CI, so if you need that for your project, you should contact him. And he's also working on testlink server, so you can run all those testlink things locally and just use their API for the browsers. Yeah, last thing, to find modules, you npm search or your component search, you'll always find something. And if you don't, write something and npm publish. Sweet, thanks.